Every design is opinionated. Accept that. Will this component be data-centric or domain-centric? If domain-centric, will it be mutable or immutable model? Then the storage. Will it be a document database or a relational database? If relational, will it be EF Core? Will it be Dapper? I have good news and bad news about that. The good news is that there's really nothing wrong about having an opinion. The bad news is that some opinions do not go with some requirements, so you might make costly mistakes with that. Another problem is that not every opinion works well with just any other opinion you might have at the same time in the same project. You might create problems for yourself in more than one way. All that makes our job more complicated, but in a funny way, let's say it like that. The question is about mixing mutable and immutable designs with EF Core and Dapper. That is precisely what I want to show you here. I will develop two models that do the exact same thing, one mutable, one immutable. And we will discuss the options, how they work, how useful they are in code, and what are the options to persist them in the database. It will be a bit complicated, so let's get to code quickly. And I hope you will enjoy it. This is an example immutable model. This immutable class models a money transfer. It contains a reusable object with fixed scalar data. But there is also a polymorphic object that tells whether someone has approved the transfer or not. The approval is critical for what the transfer allows us to do with it, and it will be the principal source of complexity when it comes to choosing how we persist this model and its mutable variant. A transfer instance will evolve through a sequence of states, and we must keep track of its current state in the database. The core data are just scalars. You can save these into the database very easily. But the approval record is what causes concerns. It is a clear candidate for a union type. Union types are coming to C# at last. Here it is a closed hierarchy of immutable records. Remember, I'm still working on the immutable domain model. And so before we adopt that as a decision for this entire component, the decision to use an immutable model, we need to see how we would use it. So watch me do it. I will start from the pending approval, and then I want to approve by one and the other employee or to reject it after all. And so, in the best tradition of immutable design, we make the mutation methods that return a new immutable instance precisely on the types that support that operation, and no other variant supports it. It would be an illegal operation in other variants. Also, pending approval supports rejecting by a single employee, partly approved supports rejecting, and let's also spice it up by letting somebody reject a previously approved transfer. This is an interesting complication. It is common in immutable designs to first isolate a subtype that has the operation you need, and only then to invoke that operation. The compiler wouldn't let you anything else. Can we do it better? I see two possibilities here. One is to define interfaces, then make the appropriate records implement one or the other or both. That will have an immediate simplifying effect on the caller. Any approvable record variant will have the approve method, and so it is done in one line. There is an interesting coding pattern that comes from this design. You can try to downcast the base type and then see what you got and use the null propagation operator to optionally make a call on a possibly non-existent object. We would refer to this design as forgivable design or optional call or whatever you like. So we can get back to the immutable domain model and implement this capability right there using functional programming style. Define an extension on the root type and define a forgivable approve method that applies to the entire hierarchy. Now, why am I showing you all this? It's because we have two things here to address. One is how do we use the system of types, and the other is how do we persist it. The data model was very simple and straightforward, and you can save it to the database. And now we are using the best tools we have, such as functional programming, to make these type also easy to use. You would just call try approve on any instance. This is how you get the famous Fluent API, which is the signature of functional domain models. This is the tremendous simplicity that makes immutable models favorable in many designs. What you have seen so far in the immutable variant is the data model that you can store into the database directly. However, it effectively dismisses the use of EF core because everything is immutable there, and EF core has trouble to work with immutable data, and worse yet, EF core doesn't support hierarchies of value types such as that 4-eyes approval. So what if our decision is to use EF core instead? Let's try it out. We need a mutable variant of the 4-eyes approval. Then, because EF core doesn't support polymorphic types that are not entities, we need to make a flat mutable class with union of all properties from all subtypes we had. We must make all these free fields nullable because not every variant of the 4-eyes approval supports all three of those. What you are witnessing here is that mutable design is immediately resurrecting Boolean flags and nullable fields because it naturally leans to EF core. If I wanted to use Dapper with mutable design, I would use the same immutable variant for this class and ditch all this. I told you, some opinions don't work well with each other. We might add a clever property to query the approvers by returning an empty array if there are none, but the approving operation is open to failure. It must check whether approving is allowed, and only if so, do it. Then comes the forgiving design. Alright, you get the picture. Rejecting will be similar. It's complicated, but it's so typical for mutable designs. It is all aimed at simplifying the usage. So we create the 4-eyes approval that requires approvers. Ask if you are free to call the method and only then make the call. Or alternatively use the forgiving methods try approve, try reject. This will just work, and it is equally simple as using the immutable design. However, this design is ready for EF core. On the other hand, it is much more convoluted. It's really not clear how we should use these classes if we just read its methods. That's what we usually refer to as accidental complexity. That's the complexity that is not the part of the problem, but the part of the implementation. This class is EF core ready, but very unpleasant to use. And then we get to a much bigger problem, the transfer. We will now continue with the transfer class, which will be the source of the greatest complexity in this demo, and you will see it. I will implement it in the immutable design first. It will be very simple, and then in the mutable design, and it will be very complicated. That's how it is. But before I show you that, let me ask you for a favor. You know that this channel and everything on this channel is free for everybody, but that is only thanks to the patrons, the people who are sponsoring this channel on my Patreon page. So if you like what you have learned from this video and other videos on my channel, then please consider joining the growing community of patrons on my Patreon page. You will get access to the source code of this video and all other videos on my channel, and you will also get access to some discounts that I occasionally post on Patreon. Thank you very much. Now let's quickly get back to code, because there is a lot of work to do to make this design complete. This is the immutable transfer again, and I want to implement transitions, state transitions. But we have simple solutions in immutable design. This is the protected helper. Then use this helper method to implement the transitions in derived classes. This is so simple. Each method belongs to appropriate types. That's the strength of the immutable design. Then how do we use this immutable transfer type? Oh, it's simple again. Prepare the core data, create a pending transfer with a pending approval record in it. Type system is protecting us from mismatching the types. It always does. Ensure the type supports the desired operation. You must always do that in the immutable design. Then add the person and remember the new object. Eventually execute the transfer if executing is allowed on this instance. And then I will show you the corresponding mutable transfer implementation. It is much longer. It uses interface segregation to separate the possible operations because this class supports all possibilities, but you will not be able to invoke just any of those. Some of those in some instances would just fail. That is what happens if you want to store the mutable entity using EF Core. I already indicated EF Core does not allow the mutation of an entity, the runtime type, I mean. That's because, if you think about it, it doesn't really make sense to have an entity which changes its runtime type. You would change the runtime types of things inside the entity, but not the entity itself. And therefore, EF Core insists on that the entity doesn't change its runtime type over its lifetime. And this is how you do that in this example design I made. These are utility conversions from this object into an object that implements any of the three interfaces. It is all aimed towards making the use of this type easier while still fully supporting EF Core persistence. So let me demonstrate. I would create an entire transfer at once. It has some approval record. But then I'm using the optional calls to add approver, and execute. I have no idea which of these calls will actually do anything or be skipped, but that doesn't matter. What matters is that only the valid calls will actually execute. So I gave you the tools to think when you make choices in your project. I have shown you an immutable design which is tremendously simple to manage and to use. But on the other hand, if you chose to walk down this path, then EF Core is off limits for you. You will have to do it with Dapper or to use the document storage. That's a completely different story. On the other hand, if your domain model warrants sufficient simplicity, internal simplicity, then you can still opt to use a full mutable model, and it won't exhibit much of its characteristic accidental complexity. You will survive the designing phase, and at the same time your design will be open for use using EF Core. If that's what you want, you will have all the benefits of using EF Core with it. I hope this will help you make some decisions.